Hello everyone, let's look at this function here. We have a ln function divided by x. And to find the derivative for this function, we are going to use the quotient rule because it's a quotient, right? You can also use the product rule by moving the x to the numerator so that there is no more quotient. It will become a product. And then you can use the power rule to do that. So we can also do that. But right now we are going to just practice with the quotient rule and then try to differentiate this function using it. Okay, so let's get started by recalling the quotient rule. Okay, so if we call the numerator the high function, the denominator the low function, when we take the derivative, we are going to be getting, right, low, right, which is the bottom function, and then times the derivative of the top function, so that's d high, minus, and then we put high, and then that's just the top function, right, times the derivative of the bottom function, so that's d low. And actually, if you look at this one, this is actually almost the same thing as the product rule, except that the sign in the middle is not plus. So if you memorize the product rule, then knowing this one would be quite easy to remember. And then what about the denominator? The denominator would be low, right? So it's the bottom function square. Okay, so now let's actually apply the quotient rule on differentiating this function. So we have f of x, f prime of x now. That's the derivative. And then what do we have here? We are going to put the bottom function first, right? We put low, so x, and then times the derivative of the top function, which will give us 1 over x. And then minus, and then high means what? The ln of x, right? So just copy that. And then times d low is the derivative of the bottom, which is just the 1, right? The derivative of the x is just 1. And then now what about the denominator? We get the bottom function square, so low, right? So we get x squared. And then, yeah, so that's the derivative, but we can simplify it by doing a little bit of extra work here. So we can cancel the x, and so that becomes a 1. And so our answer would just be 1 minus, now we have 1 times ln of x, so we get ln of x right here. And then we are getting the x squared. Okay, so there is no other ways that we can simplify this right now, unless you want to just break up the fraction into 2, which will actually become 1 over x squared, and then minus ln of x over x squared. Yeah. But usually we can just leave it as a single fraction if we are to find critical numbers. Okay, so that's it for this problem. It's actually a simple problem. What I want to show you right now is to use product rule to differentiate this function, and then we can compare and see which one you like better. Okay, so let's do it. Alternatively, right, we can use product rule. How do we use the product rule? First, you gotta rewrite it so that it will become a product. So I'm just going to copy down the function here. Then we are going to have ln of x over x, right? And how do I write it as a product? I'm going to move this x to the top. And so now it will have a negative exponent. And then you still have just that ln of x. Okay, so now what we are going to do is to do the product rule. We have two functions. One of them is this function, so x to the negative 1 first power, and then the other function is going to be the ln x. Okay, so f prime would be equal to, now we take the derivative of the first function, and then we do not touch the second, right? So we are going to be getting negative x to the negative second power because we're going to bring this negative 1 to the front, and then we got to subtract 1 from it, so we get x to the negative second power, and we do not touch the second function, so we just copy that here, and then now plus. Okay, so we are just going to copy this function here, which is x to the negative first, and then we are going to take the derivative of this ln of x. So we are going to be getting times 1 over x, right? The derivative of ln of x is 1 over x. And then now all we need to do is to simplify it, and then you can see that our answers will be the same. And so if you move this back to the bottom, then it will become negative ln of x over x to the negative second power. Let me highlight the color so that it's easier to see. So we get minus and then x squared. I move it to the bottom so that it becomes a positive 2. This exponent right here, it was originally negative 2 in the numerator. Now in the denominator, it becomes a positive 2. And then what about this one? We can also move this thing to the bottom. So if we are moving it, then we are going to be getting 1 over, right? Yeah, so we can write it as 1 over x, and then times the what? Times the 1 over x. You see what's going on here? We are going to get 1 over x squared. So we are getting negative ln of x over x squared plus 1 over x squared. And what do you see right here? We have positive 1 over x squared, positive 1 over x squared, minus ln of x over x squared, minus ln of x over x squared. See what's going on here, right? Same answer. And then, of course, we can just combine that into a single fraction if you want. So which way do you like better? If you like this video, please subscribe my channel, and then also leave me a comment, give me a like, and then also please check out my other videos. Thank you for watching this video. I will see you next time.